Hi, my name is Corbin. I'm in CST201 at GCU here, and here is my program for the Tower of Honey. So to first start, I'm going to show you my main program and show you how that looks if you are the user using this program. So at first, I give two options because there's two different methods in this program. One determines the minimum moves required to win depending on how many discs are in the game. The second tracks how much each size disc will move in order to win. And that actually doesn't depend on how many discs are in the game. So that's actually steady no matter what, which is really cool. So to start, we'll do the first option, what's the minimum moves required to win, depending on the disc. And we can go with 7 here. So if there's 7 discs, you'll need to move the disc. You'll need to make at least 127 moves to win. Show you this again. And we go to if we track a certain disc, to first we can see one is the biggest. So if the biggest one only ever needs to move once. Now if we go with something more complex than that and track that, for example, if we go with the fourth biggest disc, in every game that will need to move 8 times in order to win at the minimum. Now, my instructor actually gave me 12 tests to test these programs to make sure that all the possible outcomes this term is correct. If we test these, see the program obviously pass 12 tests. Now to go through some of the logic of this, now to determine this and to figure out how to calculate this, I looked at some of the patterns of what the minimum moves were as you increase this number. And the pattern was you times the moves by 2 and add 1. So I started the moves at 1, started the index at 2 to eliminate any too low of inputs that don't follow the actual pattern or mess up the pattern. And then loop through until you get to the actual disk number, just timesing the moves by 2 and adding 1. And then for the specific disk, it was a very similar pattern. Instead of adding 1, you just times the moves by 2 for each number of disks you go up, or each smaller disk. So I started the moves at 2, again kept the index, started the index at 2, looped through all the disk numbers, and just times the moves by 2, and then return the moves. So pretty simple methods, but it was really cool to see the patterns and see how that worked, and use those patterns to make algorithms using iterative methods to save some time, have efficient programs, and ultimately solve the problem.